remember that when you have A over B equals C over D, that there are a few rules that you can use. And practicing these rules, if you don't recognize them, it will mess you up. All right? One of the things that you can do is write this, and it will be a true proportion if you write the reciprocal of each fraction. So you can say that A over B equals C over D is the same as B over A equals D over C. So the way they put it in the book is if A over B is equal to C over D, then B over A equals D over C. We've just flipped both fractions, written the reciprocal. Okay? That's rule number one. Rule number two is you can switch the means. You can interchange the means. So if A over B is equal to C over D, then A over C is equal to B over D. We've switched the B and the C. Still true. Now you can do this with real numbers to verify that it really works. It really does work. Okay, the third rule is that you can add the denominator of this fraction to the numerator and the denominator of this fraction to the numerator, and your proportion will still be true. We'll do these with numbers in a minute. Okay, so this would be A plus B over B is equal to C plus D over D. I moved the B up. Okay, so if A over B is equal to C over D, then A plus B over B equals C plus D over D. Notice we added the denominator of the first fraction to the first numerator and the denominator of the second fraction to the second numerator. Now you can also do a combination of these things. So now that I have added the denominators in, I could actually switch the two means and I would get A plus B over C plus D is equal to B over D. So starting with this, I could come out with that man. Okay, so you're really going to have to look at these carefully to catch them. Some of them are more difficult than others. Let's do a couple of these with some numbers. Let's do some simple numbers. That's not a number. Okay. 2 over 3 is equal to 4 over 6. True statement? Yes, we've multiplied each of them by 2. All right, so let's say, can we say then 5 over 3 is equal to 10 over 6? Well, what have I done? Okay, that's right. I know you're getting it. We added the 2 and the 3 together. I brought the 3 up here and I added the 3, so I've got 5 over 3 is equal to 6 plus 4, or 4 plus 6 over 6. So 10 over 6. Now, is this still true? 5 times 2 is 10. 3 times 2 is 6. Yes, still true. Okay, let's try another one. Let's do this. Let's say 6 over 4 is equal to, doing this in my head, it's kind of hard to do. 6 over 4 is equal to 9 over 3? No. 9 over, confused myself. Okay, what I did was I switched the 4 and the 3, and so I said 3 plus, no I didn't. Yes, 4 plus 2 is 6, 6 over 4. And then I've got the 3 over here, so if the 3 is over here, 6 plus 3 is 9 over 6. Okay, to figure out if that works, the easiest way to figure out if it's really true, because what are you going to say? Well, you could say 6 times 1 1/2 and 4 times 1 1/2, that works. Or you could just cross multiply and see if they're even. Okay, So those are the rules that you need to be aware of. Okay, so that when you look at it, you have some of the problems that we have. Number 5 says, on page 367, number 5 says if x over 6 is equals y over 15, then x plus 6 over 6 equals, and then they give you question mark. So there's no way to work this by doing cross products or anything. So you have to remember the rule. They added 6 to the top, so I can add 15 to the top. So I say y plus 15 over 15. Okay, so those are some problems from 6.2.